All right, we're now going to begin the actual notes for section 4.1, Introduction to Functions, Domain and Range. There's a number of vocabulary terms that are kind of new in this unit, so we're going to record some of those, or a lot of those, on our first note sheet here. So the first one is input. We talked about input in the last video, and I would like you to record this. Some of these are a little bit longer, so you should write relatively small. So an input is the number or value that is entered for example into a function machine. And we'll see that function machine in a little video that we'll look at a little bit later. The number that goes in is the input. Okay, so an input's basically the number that goes in to whatever the function is. It might be an equation, it might be a graph that we'll look at, but the input is the number that goes in. All right, so you might guess what an output might be. Is the number or value that comes out. From a process. So if we think about what we put in, the number we put in the inputs, something's going to happen to it, and then a different number usually is going to come out, and that would be the output. All right, relation, that's a little bit shorter here. So relation. A relation or relationship, is a connection between, for instance, two people, but a relation in math is a connection between a set of ordered pairs. In other words, an x and a y value. So a connection between a set of x, y, ordered pairs. Okay? In other words, a point. Every point has an x value and a y value. So the relation is just a connection that goes from x to y. Now relations can be functions or they cannot be functions. So this is the new term for our unit here is what is a function. So a function is a math device that converts one value to another. So sometimes we think of it as a machine. So you feed a machine and input. So you put something in. It does some calculations. And then gives you back an output. I'm going to say exactly one output. So you put something in, you expect to get exactly one thing out. All right, that's one of the things with the function, and we'll talk about this. It'll make a little bit more sense when we go through some examples, but function is when you have an input and it goes to exactly one output, not more than one output. All right, and then we're going to do something called the vertical line test. This is going to be an easy test to do when we determine whether a graph is a function or not. So, vertical line test. If a vertical line, and a vertical line, remember, is a line that goes up and down. If a vertical line crosses the graph more than once, it is not a function. All right, so we'll see that example down below. Okay, we have some of those vocabulary terms and definitions done. So now let's go through and actually do some examples. Example A says, make an input-output table or use the vertical line test to decide whether each relation is a function. All right, so we're going to make an input-output table. Remember, when we have a list of ordered pairs, basically you just have a bunch of x and y values. So x, y, x, y. And so here we have an x value and a y value, so we're just going to list those. So 1, 4 is the first ordered pair, 3, 5, -2, 7. Every input, notice, 1 goes to an output of 4. So you can think of this as an input, the x is the input and the y is the output. So 1 goes to 4, 3 goes to 5, -2 goes to 7. So that is a function. Every input goes to exactly one output. So yes, each input goes to exactly one output. So that's a function. It is a function. Example number 2, or part B here, order pairs. So again, we'll make an input-output table. So x and y, x is the input, y is the output. 0, 3, 4, -3, and 4, 2. All right, so 0 goes to 3. Now here's where our issue is. 4 goes to -3, but 4 also goes to 2. So these 4s are written down here twice, but they're the same number. So if I said for an input of 0, what's the output? You'd say 3. But if I said for an input of 4, what's the output? You might say -3, you might say 2. There's 2 possible outputs for the input of 4. So this is not a function. No. The input of 4 has more than one output. So it is not a function because of that. An input has to go to exactly one output for it to be a function. A linear equation. So we've done graphs this year. And so if we make a linear equation here, we have a y-intercept of 4, so I'm just going to kind of sketch this out, and a slope of 2, so rise 2, run 1. So a graph would look something like this. Now for a linear equation, to determine if it's a function or not, we use something called the vertical line test. So basically, if you draw a bunch of vertical lines straight up and down through your graph, if those vertical lines ever cross the graph more than once, then it's not a function. Now this vertical line right here only crosses the graph once. This vertical line in the middle crosses the graph once. This vertical line here crosses the graph once. So this is a function, yes. It passes the vertical line test. What that means is, you think about the x values on the x-axis here, so let's say this is an x value of 2. All right? So follow that up to the graph, it hits exactly one y value. So the x value of 2, if you follow it up, it hits exactly one y value. It doesn't cross the graph more than once. This kind of goes back to our secret code discussion on the last page, where if we had more than one output, then that was a little bit of a problem. But with all equations that we do, with linear equations especially, you're only going to have one output for every input, so each one is a function. Now the last equation here, or part D, this equation, x squared plus 1. In the next unit, we're actually going to do a little bit more with these graphs, but here's what this graph is going to look like. Oops, let's try that one more time. This one's going to have a y-intercept value of +1, and it's going to be kind of a bowl or a U shape here. So that's what this graph actually looks like. Is this a function? All right, let's do the vertical line test. Put a bunch of vertical lines up, down on the graph. Do these lines ever cross the graph more than once? No, they don't. They only cross the graph once. So therefore, it passes the vertical line test, and yes, it is a function. Because every input just goes with one output. So it passes the